All right, coordinates and change of bases. So let's go over some notation first. You have, let's say, a basis B. An example of a basis would be the standard basis in R3 here. And this is a vector basis for the vector space V. Our basis here is a basis for vector space R3. Let X be a vector in V's, right? So you can pick any vector in R3. For example, I picked negative 2, 1, 3. Then we're going to, so the notation that we're introducing is for the coordinates of X in the vector space V relative to B. So that's a lot of things. So let's clean it up a little bit. So first off, you can express this vector X as a linear combination of the basis vectors, right? So that's what a basis is. It's a set of vectors that you can use to express any vector in V as a linear combination of those vectors. So we say that C1, C2, and Cn are the coordinates of X relative to B. So to write coordinates of X, we put X in brackets, right? So you see those brackets, that means the coordinates of X. And this B here tells you relative to which basis, because you could have several bases for each set. So that here, this indicates the actual coefficients or the actual coordinates of X relative to the basis B. The numbers you use to express X as a linear combination there. So let's see what that means in our language here. So the coordinates of X, what does that mean? I'm going to put X in brackets. So the coordinates of X relative to basis S. So the coordinates of X relative to S, these words get concise by using this notation instead, right? So they mean the same thing, coordinates of X with respect to S. What does it mean for the coordinates of X with respect to X to be negative 2, 1, 3? It means that the vector X, which is negative 2, 1, 3, can be expressed as a linear combination of the basis vectors by doing negative 2, so this is C1 here, times, so this would be C1, C2, C3, and the basis vectors here are V1, V2, V3. So you do C1 times V1 plus 1 times V2 plus 3 times V3. So we all know that this is how you write negative 2, 1, 3 in terms of IJK, right? So that when we wrote, like when you did this in Calc 3, when you wrote negative 2, 1, 3 as negative 2i plus 1j plus 3k, you are really writing the coefficients of the vector in terms of the standard basis, right? So you're writing it this way. Now it is not necessary, if this is all we're doing, it's not necessary to introduce new notation. It is necessary to introduce new notation if we're going to express a vector in terms of a non-standard basis, right? So if you have a basis that's not just IJK, then the notation is necessary, and also for moving between bases. So let's see. This example here is similar to homework problems 1, 5, and 35, right? So in these problems, you're asked to go from a non-standard basis. In this example, the non-standard basis is 1, 0, 1, 2. So to go with the notation here, that is V1 and V2, right? So we are given, what are we given here? brackets means coefficients or coordinates. The coordinates of x relative to b. So these are the coordinates of x relative to b. That means this is C1 and C2 in this context. There's C1 and C2, the coefficients of the vectors and the bases. So what does this say? So far, this says that I can get the vector x by writing it as 3, that's C1, times 1, 0, that's V1, plus 2, that's C2, times 1, 2, that's V2. Okay, so as you saw in the previous example, so I'm going to do the math here, it's 2 plus 3 is 5, and that is 4. So here you had the vector negative 2, 1, 3, and if you write it with respect to the standard basis, it just looks like negative 2, 1, 3 in a column vector, as a column vector, right? So if you write this, this is how we express vectors in general. We usually express them as a linear combination of the base of the standard basis. But if you want to use the new coordinate notation or coefficient notation, you would say the coefficients of x relative to s being the standard basis, right? The standard basis in R2 is ij, 1, 0, 0, 1. Well, that all you're doing is you're changing this to a column matrix, right? So this is the computation that you would need to do to go from a non-standard basis to a standard basis. This notation is sufficient. They sometimes want you to write things in this notation, even for the standard basis, so don't get confused. They really mean the same thing, only for the standard basis. Now, let's say this is an example like problem 9. Let's say you're going to find the coefficients, right? So brackets means coefficients of x relative to b prime. That is a non-standard basis, right? It's not ijk, it's these vectors here. And I am given that x is this vector. What does that mean? That means that I am supposed to find, what am I going to find? The coordinates, what are these going to be? They're going to look like C1, C2, C3, right? I'm looking for the coordinates of x with respect to this new basis. I'm looking for the coordinates here of x with respect to the new basis. So we're going to find C1, C2, and C3 such that if we multiply, so we are going to end up with, right, we're going to express the vector 1, 2, negative 1, and it's written relative to the standard basis, like this one, right? So we write it this way when it's relative to the standard basis, as C1 times V1, that's 1, 0, 1, plus C2 times V2, 0, negative 1, 2. So we have to find these C1, C2, C3 times 2, 3, negative 5. So we've done this computation many times before. Basically what you're doing is you have to find, so if you write it out and work your way down, you're going to try to find the solution to this system. So everything gets reduced to finding, solving a system of equations again. So let me write it this way first. Then you want to multiply this by C1, C2, C3, and you want to end up with 1, 2, negative 1, right? So one way to do this is you're going to augment this 1, 2, negative 5. You're going to augment it the b vector, so to speak, you are going to row reduce this, and this one happens to have a unique solution. It will have a unique solution because this is a basis, right? These are linearly independent. They're going to give you a unique solution when you row reduce this. And the coefficients of it, once you row reduce it, are going to be 5, -8, -2. So this will be 5, -8, -2. What does that mean? That means C1 is 5. I'll write it here. That means C1 is 5, C2 is -8, C3 is -2. What does that mean, really? It means that the coefficients of x with respect to b prime is made of these things. So to use our notation, the coefficients of x with respect to our basis b prime, this guy, are going to be 5, -8, -2. This we cannot we cannot interchange this notation with the round parentheses notation. This is reserved for just coefficients with respect to the standard basis. If you write a vector with, if you write down the coefficients of that vector with respect to a non-standard basis, then you do need to indicate it's the non-standard basis. So this is the only correct way to write the answer, really. All right.